Students, hope you are keeping safe. Today, I'll continue with the chapter that is coordination compound. So in today's video, we'll study coordination number and oxidation number. But before I start with the coordination number, let us try to know some of the important ligands, their name, their charge, and the number of donor atom present in the ligand. So I'll start with the simplest ligand, that is Cl negative. Now the name of this ligand is chloro, or you can also write chlorido. The charge carried by this ligand is -1 and number of donor atom is 1. Next, Br negative is bromo or bromido. The charge carried by this ligand is -1. Number of donor atom is 1. Similarly, F negative is known as fluoro or fluorido. Charge carried by this ligand is -1. Number of donor atom is 1. I negative is known as iodo or iodido. Charge carried by this ligand is -1. Number of donor atom is 1. H2O is known as aqua. Is a neutral ligand, so charge is 0. Number of donor atom is 1. NH3 is amine. Again, is a neutral ligand, so charge 0. Number of donor atom is 1. Cn negative is known as cyano or cyanido. Charge carried by this ligand is -1. Number of donor atom is 1. Then we have CO is known as carbonyl. Is a neutral ligand, so charge carried by this ligand is 0 and number of donor atom is 1. Then we have En. En is a bidentate ligand. The name of this ligand is ethane 1,2 diamide. It's a neutral ligand, so charge will be 0. Number of donor atom is 2. C2O4 2 negative. Name of this ligand is oxalato. Charge carried by this ligand is -2. Number of donor atom is 2. So there are more ligands you can go through. It's given in the notes. Please go through that because it's very important to know the name of the ligands, to know their charge and the number of donor atoms. In coordination compound, while calculating the coordination number, you'll be needing the number of donor atoms present in a ligand. While calculating the oxidation number, you'll be needing the charge carried by the ligands. Whereas while writing the nomenclature, you'll be needing names, you'll be needing the formulas, you'll be needing charge as well as number of donor atoms. So coordination number is basically the number of donor atoms present in the complex compound, that is coordination compound. So let us see how to calculate the coordination number. We'll try to understand with the help of examples. So the first example, COCN whole 4 charge is 2 negative. Now when we calculate coordination number, we calculate it for the compound. So the coordination number of this compound is equal to. Now for calculating the coordination number, you have to check the ligand. Now here you have only one type of ligand, that is CN, cyano, and you have 4 CN. So first you find out what is the number of donor atom in Cn. you can check the table, you'll find the number of donor atom in CN is equal to 1. So each CN will contribute 1 to the coordination number. So we'll write here 1. Now you can see here we have 4 CN. So 4 CN will contribute 1 multiplied by 4. So the coordination number of this compound is equal to 4. Let us take the next example. CO, Br2, Cl2, En. Negative. Now the coordination number of this compound CO is central metal ion, so it will not contribute to the coordination number. We have Br, Cl and En. So let's start with Br. So if you check the table, you'll find the number of donor atom in Br is equal to 1. So we'll write 1. Now 1 for each Br. We have 2 Br, so the total contribution will be 1 multiplied by 2. Next, the contribution of Cl. So we'll use here plus. Cl also is unidentate, so contribution will be 1. You have 2 Cl, so 1 multiplied by 2. Plus, En is bidentate ligand. So the contribution of each En to the coordination number will be 2. So we'll write here 2. Now you have 1 En, so 2 multiplied by 1. Now this is simple math, 2 plus 2 plus 2, that is equal to 6. So the coordination number of this compound is equal to 6. Let us see some more examples. Now look at this compound. You have species outside the square bracket. So you know this part is known as co-ordination and Untitled. Whereas the species outside the square bracket has no role to play in the coordination number. So the coordination number of this compound is equal to, you have only one type of ligand, that is Cn, and each Cn will contribute 1 to the coordination number. So it will be 1. You have 6 Cn, so the total contribution will be 1 multiplied by 6. So the coordination number of this compound is equal to 6. Next example. Now here you have 3 different types of ligands, Br, Cl, En. So the coordination number, Br is a monodentate ligand or a unidentate ligand, so it will contribute 1. So we'll write here 1. You have only one Br, so total contribution 1 multiplied by 1. Plus Cl is also unidentate, contribution will be 1 multiplied by 1. En is bidentate, so the contribution from each En will be 2. And since you have 2 En, it will be 2 multiplied by 2. So the total coordination number of this compound is equal to 6. So this is how we calculate the coordination number of a compound. So to calculate the coordination number, you just need to know the number of donor atoms present in the ligand. Now the oxidation number is the charge carried by the central metal atom or ion in the complex. Say CO, Cn, whole 6, 3 negative. Now to form this complex, cobalt must undergo excitation. That is, it must use a specific number, a positive oxidation number. So what we are going to do, we are going to calculate the oxidation number used by the metal in the formation of co-ordination compound. So So let's start with this example. Oxidation number of cobalt in this complex. So what do you do? We'll consider the oxidation number of the metal ion, that is cobalt, to be X. Using this, we'll form an equation. We'll solve the equation for X. So whatever be the value of X will represent the oxidation number of cobalt. And to calculate the oxidation number, you need to know the charge. You need to know the charge carried by the ligand. So the oxidation number of cobalt, let it be X plus. Now next is Cn, and we know Cn carries -1 charge. So we'll write here -1. And you have total 6 Cn, so -1 multiplied by 6. So whatever is there inside the square bracket, that is coordination entity, is written on the left hand side. And on the right hand side, we'll write the charge carried by the complex. So here you can see the charge carried by the complex is -3. So on right hand side, we'll write -3. Now we'll solve this equation for X. So X -1 multiplied by 6, minus plus minus. So it's X minus 6 equal to -3. So X will be equal to -3 plus 6, that is equal to +3. So the oxidation number of cobalt in the complex COCN whole 6 charge 3 negative is +3. Next example, COCl2 CN whole 2 H2O whole 2, charge of the complex -1. So again, let us consider the oxidation number of cobalt to be X plus Cl is unit-entered ligand. The charge carried by Cl is -1. So -1, you have 2 Cl, so -1 multiplied by 2. Next you have Cn, charge carried by Cn is -1. Since you have 2 Cn, multiply this by 2 plus H2O. Now if you check the table, you'll find H2O is a neutral ligand. So the charge carried by H2O is a 0. Is 0, you have 2 H2O, so 0 multiplied by 2. So this is your left hand side. On right hand side, you'll write the charge carried by this complex, that is -1. So we'll write here -1. So this is equal to X, -1 multiplied by 2, -2, -1 multiplied by 2, -2, plus 0 equal to -1, which implies X minus 4 equal to -1, X equal to +3. So the oxidation state or oxidation number of cobalt in this complex, that is COCl2 Cn whole 2 H2O whole 2 charge 1 negative is +3. Let us take one more example. So let us take this example, K3 Cr Cn whole 6. Now the counter ion is used to neutralize the charge carried by the complex. Say if the charge carried by the complex is -3, so we'll use positive counter ion, that is equivalent to +3, so that the overall charge is neutralized. Now in case if the coordination entity is positive, we'll use negative counter ion. So let us take this example. Now K3, we know K is potassium, potassium is group 1 element, and we know the oxidation number or the charge carried by group 1 element is +1. So each potassium will carry 1 positive charge. So the total positive charge carried by the counter ion is equal to +3. Each potassium will carry +1. You have 3 potassium, so that is equivalent to +3. So the charge carried by the coordination entity or complex ion is -3. So now let us calculate the oxidation number. Chromium, let it be X plus Cn, charge is -1 multiplied by 6 equal to -3. So in the cases where counter ion is given, you have to find the charge of the complex, that is coordination entity. Now say if the coordination, if the counter ion is +3, the charge carried by the coordination entity is -3. In case if you have negative counter ion, that will be written on the right hand side. If the counter ion carries -3, the charge carried by the complex entity will be +3. So if we solve this equation, x minus 6 equal to -3, which implies x equal to -3 plus 6, that is equal to +3. So the oxidation number of chromium in this complex is equal to +3. So you can take some more examples from the textbook and practice yourself. Now, such topics where you have to calculate oxidation number, coordination number, you'll get better with practice. So you have to take more and more example, practice yourself, okay? So that's all for today, for this video. In the next video, we'll be studying nomenclature. And for nomenclature, it's very important you know the names of the ligands. You know the charge carried by the ligands. You know the number of donor atom in the ligand. It's very important. So please go through the ligand chart. So in the next video, we'll study the nomenclature. Thank you.